Well, it looks like it's just me in class today, but we're going to be talking now today about multiplying in algebra class. So last class, we talked about what was called combining like terms. So hopefully you remember that combining like terms is the language we often use to talk about adding and subtracting in algebra class, or adding and subtracting algebraic expressions, okay? But obviously, as we know in math, adding and subtracting is not all we do with numbers. We also multiply them, we divide them, we raise them to powers. And so today we are going to just increase our proficiency here with our algebraic expressions and learn to start multiplying them. In order to do that, I'd actually like to back up way early. You know, I love to do this because I think that people don't realize that we've been doing the same kind of math all along, whether we're in 3rd grade or we're in 12th grade. Multiplication is multiplication, and it behaves the same way. So I want to show something to you. I want to talk about how we multiply. How we've been multiplying multi-digit numbers since, oh my goodness, I don't know, when did we learn this skill? Maybe 2nd or 3rd grade? So most of us use the traditional algorithm when we multiply, and I already am messing up, I wrote the wrong number, but we write out one number on top, the other one on the bottom. And then we do an interesting thing when we multiply. We start passing things out. The first thing we do is we take our number that's in the ones place and we basically pass out the multiplication. First, we take that 5 there and we multiply by 3, right? And we would say to ourselves, well, what's 5 times 3? It's 15. And we would drop that 5 down into the ones place and carry the 1. But then think about what we would do next. We weren't done with that 5 yet. Before we were done, we had to multiply that 5 by every single number in the top number up there. That 5 was going to multiply by every single digit in 123. So 5 times 2 now is 10, and we would carry that 1. That's now 11. Now, think about what we were really doing there. We weren't really multiplying 5 times 2. Yeah, we say to ourselves 5 times 2, but what were we doing? We were multiplying 5 times 20, because that 2 is in the tens place. That's really 123. And now we're going to multiply 5 times 1, or 5 times 100, because that 1 is in the hundreds place. And of course, 5 times 1 is 5, or 5 times 100 is 5 hundreds. And so I would end up with a 5 in my hundreds place, and then I would carry that 1 from before, so that I have 600s, 110, and 15, just from multiplying all the digits up top by that number 5. What I want to point out to you is that we passed out the 5. That's really the important thing I want you to take away from what we just did. Now what did we do? Well, as a lot of you guys know, we would then start, now that we were done passing out the 5, we would start passing out this 2, but it wasn't really a 2 that we were passing out. This 2 here is in the tens place. So this is 2 tens, or 20. What we're really multiplying by here is 20. And so your teacher would make you put a 0 there, or sometimes an X there, so that we would have nothing in the ones place, because we're multiplying with a 20, not really a 2. And 20 times 3, or 2 times 3 is 6, but that's the same as 6 tens is 60. And 2 times 2 is 4. And 2 times 1 is 2. And we would pass out that number as well. So we passed out the 5, and then we passed out the 20. Why? Because 25 is made of both 20 and 5. And so we were able to just multiply by part of that number at a time. And then, of course, what did we do with the 2 numbers back in the day once we had them? Once we found the 2 partial numbers that we got through multiplication, we added them up. We said, if I take what I got from multiplying 123 by 5 and add it with what I got from multiplying 123 by 20, then I will have all of 123 times 25. And so what I'd like to point out to you is since the beginning, since we've been multiplying, we've always realized that when we multiply two numbers together, we pass out multiplication. When you multiply one number times another, each part of the one number multiplies by each part of the other number. Now, in this case, it was just digits, but let's look at how this is going to start applying now in algebra. I just want to tell you that 123, and I hope you'll agree with me, is the same as 100 plus 20 plus 3. I mean, literally, that's what 123 means. 120 and 3. And same thing with 25. 25 is like 20 and 5. Okay, so I promise you I had a reason for that. So let's go ahead now and look at that algebra I was promising you. Okay, so I want to show you something that they often don't teach you guys until algebra, or don't give a name to algebra, but we've been doing all along. We have what's known as the distributive property. This is a property that we learn in math class that states that multiplication passes out over addition. And I should really say addition and subtraction. A lot of times when I'm lazy, I just say addition, meaning addition and subtraction, because I think of those two things as like, you know, the same thing, just forwards and backwards. Addition and subtraction are inverses. They're kind of lumped together. So multiplication can pass out over addition or subtraction. And this is what that means. So I'm going to bust out a problem that we know one way to simplify, and then I'm going to show you another way to simplify it. Okay. So here is a typical order of operations problems. We did order of operations a few weeks ago. You can go brush up on that video. But you guys know that if I was simplifying this based on the order of operations, I would go ahead and do the 3 plus 7 first. I would deal with my groupings first. So order of operations says groupings first, then exponents, then multiplication, division, then addition, subtraction. So I would do my groupings first. I'd get 10. I'd drop that 2 that I haven't used yet, and then 2 times 10 is 20. Well, what I want to show you is that I can get to the same answer another way. I can get to that same answer by passing out the multiplication. So what am I saying when I say 2 times all of 3 plus 7? You see how I have these parentheses? That's why I use the word all. This 2 is multiplying by everything in the parentheses. And so because of that, another way I could do this problem is by passing out the multiplication. I could multiply the 2 times the 3 first. Since 10 is made of 3 and 7, I could do this number a part at a time. So 2 times 3 is 6. And now I'll pass out that 2 to the 7 as well. 2 times 7 is 14. And now I'll add them at the end. And take a look. I get the same answer. And that, in fact, is what the distributive property says. It says that when you have a number that's multiplying by a sum, and see, those are two things adding, that you can feel free to just pass out the multiplication. So I wrote it up here in numbers so that you would understand, but this is how a mathematician would write it. They would say A times the quantity of B plus C. So a number multiplying by a couple of numbers adding is equal to, well, what I would get if I multiplied the A times the first number and the A times the second number. And we see that A passing out. Okay, so now that we realize that, let's do some algebra problems. Here's my first GED example. Let's start with a really simple, sweet, easy problem. So here's a problem. 2 times the quantity of x plus 7. Or you could also read this as 2 times the sum of x plus 7. But what I really need you to see here is that because of this parentheses around this x plus 7, this 2 is multiplying by all of this, all of that. Now, you might say, Kate, why don't we just follow the order of operations? It's the easy way to do it. I can't follow the order of operations here. If I tried, I would be in trouble. Take a look at this. X plus 7 is where I would start if I was doing the order of operations. Well, we know, we learned at last class, and this is crucial, that you can only add and subtract the same kinds of things. You can only add and subtract what we call like terms. X and 7 are not like terms. And so the way it stands right now, we can't currently do this addition. And so I don't have the option of starting inside my grouping. And so I must resort to the distributive property so that I can do some simplifying, even if I can't do all the simplifying. I can pass this 2 out to every term inside the parentheses. Pass that act of multiplication out. So let's do it. So 2 times x. Well, when you want a number and a letter to multiply together in algebra, you just shove them together real close like that. Number first, letter second. 2 times x. And now, because this is a plus sign and I have a positive number out here that I'm multiplying by, we are not going to see a change of sign. So I'll still have a plus sign, and 2 times 7 is 14. Okay, and I just passed out that multiplication across the entire sum. And I am now done. Remember, this is what separates my A students from my B students. An x term and a plain old constant number term are not like, so they cannot combine. So this is a final answer. This is as simplified as it's going to get. So let's try some more. Now we can make the problems a little more complex. Okay, we could multiply by not just a number, but we could multiply by this variable expression that has a number and a letter, a number and a variable. But it's that same idea here. This whole 3x is shoved up against this parentheses. So this entire 3x is going to multiply with both of the terms inside my parentheses. So let's first multiply 3x by x. Okay, well, obviously, there's only one number here. I'm still going to have that same number 3. But don't be the foolish student who just writes 3x and moves on. Remember what happened with our exponent rules. If I am multiplying 3x times another x, I actually have 2 x's multiplying. And as we know, when you have multiple of the same base multiplying, you have more than one of the same base multiplying, you can use an exponent to express repeated multiplication. And so I don't just have 3x over here. I have 3x squared, or a 3 and 2 x's multiplying. Okay, great. Almost done. Let's continue passing this out. So once again, I'm multiplying by a positive number, so I'm not going to see any sign changes. And I'm going to multiply 3x times this 7. So 3 times 7 is 21. And I just will shove that x on the back side to say it's multiplying. And that's it. I'm done with that problem. These are not like terms. I cannot combine them. I am all done. This property also comes up when we have problems that look like this. Okay, so there's 2 ways to think about this problem, and we learned one the other day where we talked about this minus sign out front. One way you can think about this is as the opposite of. But another way you can think of it, and a way a lot of students like, is if you just have a negative shoved up against this parentheses, really what you're doing here is you're multiplying by -1. Remember that we often will leave off the number 1 when it's a coefficient, when it's a multiplier, because it's silly. When you multiply by 1, nothing happens. So this negative out front is like this entire expression here inside is getting multiplied by -1. Now notice this time I have 3 terms. Do you see it? 1 term, 2 terms, 3 terms. So each one of those is going to get multiplied by -1. Well, what happens when you multiply by -1? All that happens when you multiply by -1 is a sign change. So take a look at the first term that I had inside these parentheses. The first term I had was a positive x. Well, if I multiply it by -1, it's going to turn into a negative x. Take a look at the next term that I had. The next term I had was a negative or a -5y. If I multiply by another negative, those two negatives will cancel each other out, like the opposite of an opposite, or the opposite of a negative is a positive. And I get a positive 5y. Then take a look at the last term here. The last term I had here was a positive 3. So if I multiply by -1, all that will happen will be that my positive or +3 turns into -3 or -3. And I'm done. That's all that happens. When you have a negative out front of the parentheses, it's just going to change every term's sign. And so, you know, mathematicians are like the laziest people on earth. So I have to tell you the truth. Your math teachers will not stop to explain to you why they're doing these things. They will just very quickly flip signs and you will have to follow along. So if I'm passing on a negative, every single term in the parentheses will change signs. My positive y cubed will become negative. My -2 will become positive. My positive 3y or +3y will become negative. And my -5 will become +5. And we just see that sweep through and change the signs. Okay. Okay, so now we've looked at some pretty simple examples. Now let's get a little more complicated. Let's look at what you're actually probably going to see on the GED. So here's some tricky things that could happen on the GED. Okay, there's a lot going on in this problem. There really is. But I just want to point out to you, here is the number. It's a big, ugly number, but here is the number that I'm multiplying, -2y squared. And I'm multiplying it by 3 terms. 1, 2, 3. So there will be 3 acts of multiplication. Let's pass out the first one. When you go to write each term, you should start with a sign. Okay, so this was originally a positive y cubed. But since I'm multiplying by a negative, it will change signs. So I'm going to have a negative. After your sign, you should write your coefficient. That's your number portion. The number out front with its feet on the ground. Okay. The only number that's here is a 2. So that's still going to be a 2. And then after you're done, you're going to write the variable portion with the exponent. You really need to see that the variable with its exponent, because what this y squared right here tells me is that I already have 2 y's multiplying. If I go ahead and multiply that by another 3 y's, I already had 2 y's multiplying, and I multiply by another 3 y's, I'm going to have a total of 5 y's multiplying, or y to the 5th power. Notice how those exponents just end up adding up. Okay, so I just passed out my -2y squared for the first time. Now let's move on and multiply it by the next term. Okay, so again, the first thing you're going to do is your sign. So my sign is going to change from a negative to a positive. Why is it changing? Because I'm multiplying by a negative number out here. Now I'll deal with the number portion. Remember we said after the sign we'll do the coefficient. So 2 times 4 is 8. And now we'll do with the variable portion. I already had 2 y's multiplying, and here's another y, so now I'll have a total of 3 y's multiplying. I already had 2 y's, and there was another y, that's 1, 2, 3 y's. Okay. So great, I just passed it out again. Now let's pass it out for the last time. Okay, again, I'm multiplying by a negative number, so my sign will change. I multiply my numbers together, 2 times 2 is 4. And this one, I only have one variable portion, y squared. We'll still have y squared. And that is a long, ugly answer, but that is correct. Okay. Now, I know a lot of math teachers who teach math like there's all these different rules. Like we have the multiplying rule, and then we have the exponents rules, and then we have distribution rules, and then we have multiplying binomials and trinomials. And the deal is we do the same thing every time. So here's a very, very, very typical GED math problem known as multiplying binomials that I want to show you follows this exact same rule. Now, your teacher might have taught you a different way to do this. If you already know a different way to do this, that's great and grand. I'm not trying to change your mind. We'll get to the same place in the end. We're just using different language, I promise. But I just want to show my students that this problem that we often say is a different rule, we'll call it the FOIL rule or multiplying binomials rule, follows the exact same thing. It's the exact same rule. Basically, every term in the first number, the first parentheses, has to multiply by every term in the second number, the second parentheses. It's kind of like we're multiplying two-digit numbers. If we were multiplying two-digit numbers, first we'd pass out that 3 to both the numbers up there, then we'd pass out that 3 to both the numbers up there. So same thing here. I've got 2 terms in my first parentheses. I've got 2 terms in my second parentheses, okay? And I'm just going to be real orderly about how I pass this out. So first I'll pass out the first term, the x. So let's try this. X times x. Well, we know when we have repeated multiplication, we use an exponent. So x times x is x squared. 2x is multiplying. Now I'll do x times positive 3. Well, I'm passing out a positive. X has no sign in front of it, so I know he's positive, so I won't see a change of sign. And how do I multiply an x and a 3? Well, I just write the number first and the variable second. That's it. Okay, so now I finished passing out my x. I'm done with it. Now it's time to start passing out my second term. Notice I circled the negative sign with that 2. That is a negative 2 I'm passing out. So negative 2 times x is negative 2x. And negative 2 times positive 3 is negative 6. And I'm almost done now. Just remember, just like back in the day when we got our 2 answers, the last thing we did at the end when we were multiplying a 2-digit number by a 2-digit number was add them up. So I'm going to do the same thing here. I'm going to add. But remember, in algebra class, we only add like terms. We can only add the same kinds of things. So the only terms I see here that are like are 3x and negative 2x. So x squared has no one to combine with. He's just going to drop. But positive 3x and negative 2x squared give me just 1x, or as we always write, plus x. Now let's have a conversation about that. Could you write plus 1x? Yeah, you could, but you're going to look like an English major because math majors always write a simplified answer. We want our answer as simple as possible, and we all know that 1x is just an x. And then there's nothing to combine with my minus 6 or my negative 6, so I just drop it. And there's my final answer. Okay. One more problem I want to show you. I want to show you how this skill could come up in a word problem. So last example, and we'll be done. Here we go. What if they told me, find the simplified product of 2x minus 1 and x plus 6. Now, I know a lot of students who would just lose their snot here, but don't forget what product means. Product means the answer when you multiply. Okay. So I'm looking for the answer when I multiply. And what am I being asked to multiply? I'm being asked to multiply this whole big number with this whole big number. Mathematically, if you want to take an entire number and multiply it, and it's complex, it has a couple of terms going on, you're going to need to enclose it in parentheses. That whole number times that whole number. And look at that. Now it's just an application of that wonderful distributive property that we learned, where we pass out every term in the first parentheses with every term in the second parentheses. Now, if you learned the phrase FOIL, to do this. Don't worry, there's nothing wrong with FOIL. I'm foiling too, even though I didn't call it foiling. I'm passing out everything in the first with everything in the second. So first I'll multiply 2x by x. So of course, my number will be a positive 2 there, and x times x is x squared. Now I'll multiply my 2x by positive 6. Again, I've only got positive numbers, so I'll end up positive. 2 times 6 is 12, and I'll just shove that x on the back side to say they're multiplying. Now, we finished passing out the 2x. The 2x went to every term in the second parentheses already. We're done with 2x, but it's time to take -1 and multiply it. What happens when I multiply it by -1? Only a sign change. So my x will turn into a negative x, and my positive 6 will turn into a -6. Great. Now we're almost done. We just have to add anything that will add. Well, I can see that 2x squared, there's no other squared terms, so nothing will add with it. But I sure do have some like terms here. Plus 12x, I can take away an x from that. So if I had 12 x's and I took away an x, remember there's like an invisible 1 there, then I would have 11 x's left. Now be very careful. Here's what some students do wrong. In fact, let me use red. Some students will just write 11x. If you just write 11x like this without anything in front of it, you are making this 11x multiply with this 2x squared. These things were not multiplying. This was a list of 4 numbers adding and subtracting. It's super important that you have a sign in front of this 11x. So let me erase the 11x, scoot it over a little bit. 11x needs a sign in front. So you have to ask yourself, is that positive 11x or negative? It's positive, and so I'll put a plus 11x. And then there's nothing to combine with the -6, so it just drops. And this is my final answer. There's no more math that I can do here. This is as simplified as this is going to get. And so I am all done. All right, so if you have any questions about this, shoot me an email or drop it in the comments and I'll be happy to answer.